Okay, so in this video we're going to find the inverse of a function, and in this particular question, the first part of the question was, is the function one-to-one? In other words, does it even have an inverse to begin with? And the function on the screen is a one-to-one function. So what I'm going to do is split this up into two parts. First, I'm going to find the inverse of the function, which is probably what most people are interested in. How do you get the inverse? And then after I find the inverse, I'll prove that the function is one-to-one, which proves that the function does have an inverse. So first, to find the inverse, I usually start by writing y instead of f of x. And then you simply interchange all x's for y's and all y's for x's. So where there was a y, put an x, and where there were x's, where there were x's, put y's. And then your goal is simply to solve for y. So we're going to multiply by y minus 3 on both sides. And then on the left side, I can distribute the x. And so my goal is to solve for y. So I want to get the two terms with y on the same side. So I can subtract y. And then also, I want to get the two terms without y on the same side, so I'm going to add 3x, 3x. So on the left side, I've got yx minus y. On the right side, I've got 4 plus 3x. And then to isolate the y on the left, since both terms have a common factor of y, I can pull that out. And then last, to get y by itself, since it's multiplied by x minus 1, simply divide by x minus 1. And that is our inverse. And so, of course, if you're able to do the algebra to find the inverse, that's probably a good clue that the inverse does exist. Or, on the other hand, if you get stuck in the algebra of trying to find the inverse, that might be a clue that the inverse doesn't exist. It might also just be a clue that you're stuck in your algebra. But as I said at the beginning, this function does have an inverse, which we just found. So let's go ahead and do the proof that this function is one-to-one. Now this is probably a more formal proof than would be required in a lot of classes, a lot of algebra or pre-calc classes. But to prove that a function is one-to-one, well, for instance, we know this function is not one-to-one because it doesn't pass the horizontal line test, right? But mathematically, the function is not one-to-one because we can obtain the same y value with two different x values. For instance, if we plug -2 into the function, we get 4, and also if we plug 2 into the function, we get 4. So the way that we prove a function is one-to-one is if we assume that we take two different x values from the domain. In this case, the two different x values are a and b, and those two x values correspond to the same y value, then what we must be able to conclude, under this assumption, what we must be able to conclude is that really it's not two different x values, really that's the same x value, right? So the only way in a one-to-one function, the only way you can get the same y value is to be working with the exact same x value. Right? To take a simple function that we know is one-to-one, f of x equals x. Right? So for instance, if I plug 2 into that function, there's only one way I'm going to be able to reproduce that y value, and that is only if I keep using this same x value. There is no other x value that is going to produce the y value of 2. Right, so the way you would prove, let's see, going back to our function that we started with, we would start with this assumption. Okay, so what I'm going to do is go back to my formula for my function, plug a in for x. Right, so up here I'd have a plus 4 over a minus 3. And same thing on this side, except I'm going to use the letter b. And now our goal is to do some algebra on both sides and conclude that a is equivalent to b. So all I'm going to do here is cross multiply. So we would get end up with that, and then this looks a little strange, but let's go ahead and FOIL on both sides. So if I do that, okay, so I can see some terms that are common on both sides. AB and AB, I can just subtract that from both sides. I've got negative 12 and negative 12. I can add that on both sides. And so what am I left with? Let's just rewrite this so it looks a little neater. Well, let's see. If I try to combine the terms with B, I would add 3b on both sides. And let's see here, I could add 3a on both sides. So let's see, that would eliminate those guys and eliminate those guys. So that gives me 7b equals 7a, and sure enough, then if I just divide by 7, I've concluded that a and b must be the same value. So that proves that the function was one-to-one to begin. Of course, you probably wouldn't get a question that asked you to find the inverse if the function wasn't one-to-one to begin with, so we probably already knew that. But that is a formal proof that the function is one-to-one.